AP PreCalculus, looking at notes 11.3, analyzing the graph of trig functions. Basically, we're going to be looking at transformations and see how the numbers affect the graph. What you want to do first is get your calculator out, put it in Radian mode, and to do that, you hit Mode, and then go to Radians, hit Enter, and then hit Second Quit. Then go to Second Window to change your table setup. Set up your table to be starting at 0 and set your table set to pi/4. In the window button, go to y or x min to be 0, x max to be 4 pi, y min to be -4, y max to be +4. Graph each of the functions below in the indicated interval. For each function, state the range, period, amplitude, and vertical stretching, horizontal stretching, vertical shrinking, horizontal shrinking that the mother function undergoes to obtain the graph of the function. So we're going to answer these questions first, and then we'll use our calculator to look at what the graph's going to look like. So going back to earlier in this year, how does this 3 going to affect the graph? Us multiplying by this 3, this is going to dilate the parent graph. So this is all in relation to parent graph y equals sine of theta. We're going to dilate vertically by 3. What that means is if the parent graph looked like this, which it does, if we dilate this by 3, instead of going up to 1, we're going to go up to 3, back to 0, down to -3, and then back up to 0. How does this 2 affect the graph? Well, that's going to dilate it horizontally by a half. So that means that the period, let's forget about the dilation of vertically for a second. If the graph looked like this, if the parent graph looked like this, and it's dilated horizontally by a half, instead of the period being pi, or 2 pi, I'm sorry, period's going to be 1 pi. So that means we would have to fit this entire graph. Do this in blue. You shouldn't be writing this part down. I'm just trying to explain what each of these things would do. Dilating it horizontally by a half would look like that. The whole thing gets shrunk quite a bit. So let's see if we can figure out what this would be then. So here's what I suggest when you do this. Identify the midline first. Now the midline is going to be changed if there is vertical displacement, if you're translating the graph up or down, and we haven't done that. So the midline is still here on the horizontal axis. I would then figure out where the period starts and ends. Since there's no horizontal shifting, which is called a phase shift for trig functions, it still begins where it began for the parent graph, which is at 0. And since the period just got cut in half, because it's a horizontal dilation by a half, this is going to end at pi instead of ending at 2 pi. Once you know where it begins and ends, then it's pretty easy to figure out where the middle is and where the 1/4 and 3/4 are. So from here, identify where sine is going to be on the midline. From memory, sine is on the midline at the beginning, middle, and end of the period. A quarter of the way through, sine is usually 1 above. Since this 3's here, it's going to be 3 above the midline. 3/4 of the way through, it's usually 1 below, but since it's dilated by 3, it's going to be 3 below. So one period is going to look something like this. If we continue this for 2 periods, 2 cycles, I should say, it's going to look something like this. Now let me bring in this graph from Desmos. You're allowed to use your calculator on this. The directions say you can. If we were spending more time on this, which we normally do in PreCalculus, we usually spend a couple weeks on this. But for PreAP, PreCalculus, it seems like maybe we don't have the time to do that. So this right here is the sine graph. And then we can see, let me change this y max to 2 pi here, or x max to 2 pi. We can see here that this graph tell you what, let me just bring this baby in. You don't need the white graph, that's just the parent graph. But comparing the parent graph to F, which is the purple one, notice how the purple one, it goes up and down to negative and positive 3, and the period gets cut in half. It goes from 0 to pi is 1 cycle. So to answer all these questions now, state the range, period, amplitude, vertical stretching. So we stated the vertical and horizontal stretching. There's no vertical shifting, there's no horizontal shifting, so that's done. And the range is going to go from negative 3 to 3. The period for this is pi. Amplitude is the absolute value of A. The amplitude is the distance that the graph goes from the midline to its highest or lowest point, and that's 3. So we're finished with that question. Let's go on to the next one. Graph g of x, which is 2 times sine of the angle 1/2 theta plus pi from 0 to 4 pi. Now, I would like to change how this looks a little bit. We don't like our coefficient of theta to be a half. We want it to be 1. To do that, we're going to factor out a half. It's going to make this theta plus 2 pi. Now, why does that matter? Well, this goes back to our understanding and learning of transformations when this class started many, many moons ago, back when you were allowed to go out in public. That's how long it's been. This 2 pi translates the graph to the left 2 pi. If you don't factor the half out, you might think, well, this translates the graph to the left pi, but it doesn't, it's 2 pi. So let's write down some of these transformations. So we are going to have this 2 is a vertical dilation by 2. And then this half here is a horizontal, got to be careful about things that happen horizontally, dilation by 2. It's the reciprocal of that number. And then we also have to translate this graph left, horizontal translation left by 2 pi. Now here's something that doesn't really affect the graph. See, if you translate it horizontally by 2 pi, the period for the parent graph was 2 pi already. So if you take it and translate it left by 2 pi, you're not going to notice any difference in the graph whatsoever. So I'm just going to draw a quick sketch of this, and then we will look at our calculator and see how this works. When we draw the sketch, you want to find the midline first. Since there's no translating up or down, the midline is on the horizontal axis. It hasn't changed. After we have the midline, then we want to figure out where this graph starts. This had a horizontal translation left of 2 pi. So that means that this graph starts all the way over here someplace at 2 pi, which is, this graph doesn't even show that far. So it's going to make this more complicated. Since the period for this is now 4 pi, I'm going to write that down, because there's a horizontal dilation by 2, this is going to end 4 pi after it starts. If it starts at negative 2 pi, it's going to end at positive 2 pi. So this is the end of one period. Halfway between, the middle is going to be at 0. 3/4 of the way is going to be at pi, and 1/4 of the way through is going to be over here at negative pi. Now I know this left part here is not to scale, and that's because I don't have enough room to do this. But we can fix this, and I'll show you how to fix it here in a moment. From memory, when is sign on the midline? So on the midline, the beginning, middle, and end of the period. 3/4 or 1/4 of the way through, it's above by 1. Since this is vertically dilated by 2, it's going to be above by 2. And 3/4 of the way through, it's going to be below by 2. If we then expand this from 0 to 4 pi and just follow this pattern, so we are on, below, on, we're going to be above, and then on again. So at 3 pi, we're going to be above by 2, and then at 4 pi, we're going to be on the midline. So the graph would look something like this from 0 to 4 pi. Let me bring in the graph from Desmos, because you're allowed to use a calculator for this. So here is the graph from 0 to 4 pi. The white graph would be the original function, and then the blue graph is function g. I like to have the parent on here so it's easier to compare them with each other. The scale's a little bit different on these. Anyhow, the graph's going to look something like this. The blue graph's what we're concerned with. Once again, you're allowed to use your calculator for this. I was just showing you how to do it by hand because I think that's important as well, even though you won't be tested on how to do it by hand. The range for this function is going to go from -2 to 2, and then the amplitude is the absolute value of the lead coefficient, which is 2. Moving on, number 3. We're supposed to graph h, which is -2 times sine, and then we got our angle theta minus pi over 2 plus 1. Let's label this stuff up here. This plus 1 is called the vertical displacement. That's how far the graph translates up or down. This pi over 2 is called the phase shift. That's a special name for trig functions, which just means translated left or right. And then this negative is going to reflect the graph vertically. And this 2 is going to dilate the graph vertically. Let's write all that stuff down. So we're going to have a vertical dilation by 2. I'll tell you what, let's do the reflection before that. Really dumb teacher. Let's do reflections first. Vertical reflection. That's because the lead coefficient is negative. Then vertical dilate by 2. And then we are going to have a vertical displacement Vertical displacement just means translating up. It means moving up by 1. And then we're going to have a horizontal, well, it's called phase shift. We would, in our other graphs we did, we would say move horizontally, translate horizontally, shift horizontally. This is called a phase shift when it's a trig function. Phase shift is going to go right pi over 2. So when you graph this, graph the midline first. Because of this vertical displacement of 1, the midline is now at 1. It's not really part of the graph. That's why I made it dashed. From this midline, normally we'd go up 1 and down 1 for our graph. But because of this -2, we're going to go up and down 2 from this graph, from this midline, I should say. The phase shift is positive pi over 2, so that means that's where this graph begins. There has been no change to the period length because there is no horizontal dilation. So this is going to end at 2 pi to the right of pi over 2, which is going to be right here. From 0 to 2 pi, it's 8 boxes. So from pi over 2 to 5 pi over 2, it's also 8 boxes. Halfway between that is the middle of the period. And we got 1/4 of the way through and 3/4 of the way through. From memory, sine touches the midline, beginning, middle, end of the period. Sine is above the midline 1/4 of the way through. But since this is a -2, instead of going up 1, we're going to go up 2, and instead of going up 2, we're going to go down 2. It's 2 because this is dilated by 2, and it's in the opposite direction because of this vertical reflection. So from the midline, we go down 2, and that puts us here. 3/4 of the way through, normally you go down 1, but since this -2 is a coefficient, we're going to go up 2. We're supposed to graph this on the interval from 0 to 2 pi. That's kind of silly. We'll just put as many points on here as we can. So following the pattern, if we go to the left here, we're going to have a point here at 0, 3. If we continue going to the right, we're going to have a point at 3 pi -1. And then at 7 pi over 2, 0. And then at 4 pi, 3. So drawing by hand, the graph looks something like this. I'll pull the graph in from Desmos because you're allowed to use a calculator for this. Before we do that, let's answer the rest of these questions. What's the range for this? Well, it goes from -1 to 3. What's the amplitude for this? It's the absolute value of the lead coefficient, which is 2. And the other question we're supposed to answer, what's the period for this? The period is still 2 pi. So we pull this graph in from Desmos. Again, I like to have the parent graph on here as well to compare them. To get rid of the stuff that I just drew. So we can see this graph here has the midline here at 1, goes up as high as 3, is down as low as -1, comparing to the parent graph, which is the white one. Good enough. All right, moving on. Based on your observations, what graphical properties of f of x equals sine of theta do the values of a and b affect when the graph of g of x is this? Well, a, as we already know, is going to affect the vertical stretching of the graph and if there's a reflection, which we knew that already. So what's it have to do with sine? It's going to affect the range. And I'll just put in parentheses for emphasis vertical dilation and reflection is what A can do. Reflection if it's negative, it's a dilation if it's anything other than 1. How does B affect the graph? Well, B is going to affect the period. Because as we already know, B causes a horizontal dilation. All right, if possible, identify the period, amplitude, and range of each of the functions below. All right, and some of these we're going to just draw a little sketch before we answer these questions. Boy, we got a lot more to do here, don't we? Okay, so for each of these, we got to identify the period, amplitude, and range. I'm just going to throw this in for each of these. All right. There's no vertical displacement, so we want to look for that first. This 3 is going to stretch the graph vertically by 3. So that means the amplitude is the absolute value of 3, which is 3. So the range is going to go from -3 to 3, inclusive. This 4 shrinks the graph horizontally. It's a horizontal dilation by 1/4. So instead of the period being 2 pi, the period is going to be 2 pi times 1/4, which is pi over 2. That is a short graph horizontally. B, I don't like this written this way, so I'm going to write it as half times theta plus, if I divide this by pi over 4, it's going to be, or divide by 1/4, that's going to be the same thing as 8. No. Yeah. No. It's not a half. Sorry, this is a 1/4. Yeah, which does make that an 8. All right, so when we're looking at this graph's going to go to the left 8, horizontal dilation of 4, vertical stretch of 4. So the period, since it's stretched, dilated by 4 horizontally, instead of being 2 pi, it's going to be 8 pi. The amplitude is the absolute value of the lead coefficient, which is just 2. So the range, instead of going down to -1 to +1, it goes -2 to 2. See, this gets more complicated when you have this vertical displacement. Let's do amplitude first. Amplitude is the absolute value of -2. Absolute value of -2 is 2. The range, it's going to go 2 above and below the midline. The midline is at y equals 3. And if you go 2 above that, you're at 5. If you go 2 below that, you're going to be at 1. So the range is going to go from 1 to 5. The period for this 2 is a dilation horizontally of 1/2. So instead of the period being 2 pi, you cut it in half and you get 1 pi. H, the period for this is 2 pi. This 1/2 means that you dilate it horizontally by 2, so we double the period. It's going to be 4 pi. Amplitude, sorry, the amplitude is a word that is used to describe the distance from the midline to the highest or lowest point on the graph. And secant goes up and down forever. It has no amplitude. For the range, our midline is at y equals -4, and we're supposed to go up from this 3 and down from this 3. So if we go up from this 3, we're going to be at -1. If we go down from this 3, we're going to be at -7. So we're going to -7 to -1. G, tangent once again goes up and down forever. It has no amplitude. The period for tangent is pi. This 1/3 is a horizontal dilation by 3, so the period's 3 pi. The range, tangent goes up and down forever. And us translating the graph up 2 isn't going to change that, so it's all real numbers. For secant, let's change a lot about what this looks like right here. Let me write this as 3 cosecant, factor a 2 out. So that would be theta minus 3 pi over 2. This graph is translated to the right 3 pi over 2, which doesn't affect these answers. It's translated down 1, which does affect these answers. It is horizontal dilation by 1/2 and vertical dilation by 2. Amplitude does not exist for cosecant. That's a term only reserved for sine and cosine. The period for this is going to be pi because the parent's period for this is 2 pi, and we're cutting it in 1/2 because of this 2. The range for this, the midline is at y equals -1. We're still supposed to go up from this 3, puts us at 2, down from this 3 is at -4, and I just misspoke once again. That is not the range. And I screwed up this one as well, this one up here. That is not the range. If this was sine or cosine, that would be the range. So that was wrong. Let me finish F, then we'll go back to D. If this goes from -4 to 2, that means that we have a dot up here at 2, and it goes up from there, and there's a dot down here at -4, and it goes down from here. So this range is going to go from -infinity to -4, and then pick up again at 2 and go to infinity. That's how D would work as well. So there's going to be a dot at -1 and go up. There's going to be a dot at -7 and go down. So the range for this is -infinity to -7 inclusive, and then from -1 to infinity. Forgive me for that. Pictured below is the graph of a trig function f of theta. Use the graph to answer the following questions. So this is just a parent graph. Question 1, which parent graph is this? Well, hopefully you can tell this is sine. This is a sinusoid wave, and it's starting on the midline. So we will say that f of theta is sine of theta. What is the period if you add 2 to this? That doesn't affect the period. If you multiply the inside by 1/2, well, that's going to double the period. So the period's going to be 4 pi. What's the domain and range of this? Well, the domain's not going to change, fools. It's all real numbers. The range for this, since we are doubling the y values, it's going to go from -2 to 2, inclusive. What's the range of this function? Well, the range is affected by both of these numbers. The midline is at -3, and we have to go up from this 3 that's going to be at 0, and down from this 3 is going to be at -6. So the range is -6 to 0. Suppose the graph of k of theta equals f of theta minus pi over 2 were graphed. Which trig function would result? Well, if we move this to the right pi over 2, let's just do that real quick. So we got this graph right here. If we move this to the right pi over 2, I don't understand the question. Which trig function would result? None of them would result. Now, if this were translated left, pi over 2, this was sine, right? Yeah, this was sine. Hey, let's change this question. Let's change this to theta plus pi over 2. If we change that, which trig function would result? Well, if we take this function here, we would move it to the left pi over 2, we end up with cosine. That's what this question was intending to ask, and I must have mistyped it. I apologize. K of theta would equal cosine of theta, because if you translate sine of theta left by pi over 2, it coincides with cosine of theta. All right, moving on. Pictured below is a graph of a trig function. 6, what is this trig function? Well, this is clearly secant or cosecant. Hopefully that's clear to you, because those are the ones that have this shape. Which one, cosecant or secant, begins the period at 1? Well, that's going to be secant. So this little fella here is secant of theta. Identify the domain and range. Well, the domain is all real numbers except the vertical asymptotes. We got one here happening between 0 and 3.14, so that would be 3.14 over 2, which is pi over 2. And then how far apart are these? These are pi apart. So we say pi over 2 plus pi k, where k is an integer. What's the range for this? Well, the range goes from negative infinity up to -1 inclusive, and then goes from 1 to infinity. 8, identify the range of the function g of x. So this number affects the range, and so does this. This is the one I made a mistake on earlier in the notes. So if the midline is at y equals 3, and we are supposed to double the distance that this graph goes from this, it's going to go up. Usually it goes up 1, it's going to go up 2 to 5, and it's going to go down. Instead of 1, it's going to go down to 1. So at 5, there's going to be the bottom of a parabolic type thing, and at 1, there's going to be the top of a parabolic type thing. So the range for this is negative infinity to 1, and then 5 to infinity. Now identify the period of the function. Well, this 4 is going to take the period and it's going to dilate it by 1/4. So the period is going to be, normally it's 2 pi, dilate it by 1/4, the period is going to be pi over 2. Describe the behavior of the graph of f of theta as theta approaches 7 pi over 2 from the left. Let's look at it. 7 pi over 2 . So this is pi over 2. This is pi. This is 3 pi over 2. This is 4 pi, or this is 4 pi over 2, which is 2 pi. 5 pi over 2. And then we have 6 pi over 2. And then we have 7 pi over 2. Well, 7 pi over 2, we're going to have a vertical asymptote again. So if we approach this from the left, it's going to be approaching negative infinity. As we get closer to 7 pi over 2 from the left, this is going to be going down forever. It's going to be going negative infinity. Well, it's difficult to explain my reasoning. Let's say this at theta equals 7 pi over 2, f of theta has a vertical asymptote. As, let me write this using limit notation. The limit of f of theta as x approaches 7 pi over 2 from the left, this is equal to negative infinity. If you want more explanation, as x approaches 7 pi over 2 from the left, the graph goes down forever.